we're looking at today is 4.8, eating up the lunchroom budget. So let's go ahead and jump right in. So for the first part, we're looking at equivalent equations. The pairs of equations below are equivalent. So they are equivalent. What we have to take and do is determine what was done to the first equation in order to obtain the second equation. For example, everything multiplied by 5, or multiplicative property of equality. If more than one operation was performed, please indicate the operations and the order they were performed in. Okay, so for number 3, we have 6x plus 4y equals 20, and we ended up with y equals negative 3/2 x plus 5. So what's the first thing we had to do in this in order to get this y by itself? We subtract 6x. So then we'd have 4y equals negative 6x plus 20. Then we need the y by itself, so how do we get rid of that 4 on the y? We divide by 4. And that will get us y equals negative 3/2 x plus 5. So this one's the most complicated. The other two are much simpler. So you're either multiplying or dividing to get between the two equations. So it's always going from the first to the second, okay? So make sure you know which way you're going. All right, for the next section, we're determining whether or not the pairs are equivalent. And if they are, what operations were used to go between. So for number 4, we have 54x minus 42y equals 90. So how do we get from 54x to 9? 9 times what is 54? 9 times 6 is 54. 7 times 6 is 42. 15 times 6 is 90. So all the numbers work out, but what do we notice? The 42 is negative here, but the 7 was positive, so not equivalent. Almost equivalent, but not because of that minus sign right there. All right, for number 5, we have 12x plus 9y equals 21, and 4x plus 3y equals 7. So how do we go from 12 to 4, 9 to 3, and 21 to 7? We divide by 3. So they are equivalent. All right, the next section is all about literal equations. So solve each of the equations below for y. Put the equation into slope-intercept form, which remember that's y equals mx plus b. Show your work and justifications. Yes, I do want you to show your work. So for number 7, we have negative 5x plus y equals 12. First thing we need to do is move the 5x to the other side. So we add 5x over, so addition. So we have y equals 5x plus 12. And that's our answer. That's all the further we had to go with that. The next one, we have 6x plus 2y equals 12. First thing we want to do is get the x to the other side. So we subtract 6x. So subtract. We end up with 2y equals negative 6x plus 12. Now, we can't have the 2 attached to the y, so we're going to divide everything by 2. So we end up with y equals negative 6 divided by 2 is negative 3x plus 12 divided by 2 is 6. So we did division. So that's what you guys are going to be doing for this. You're just putting them into slope-intercept form. So y equals mx plus b, solving for y. All right. Matrix multiplication. So I'm going to do all of this with you because matrix multiplication can be rather tricky, but hopefully it'll make sense. So the equipment manager for the school athletics department is attempting to restock some of the needed uniform and equipment items for the upcoming seasons of baseball and football. It has been determined, based on the current levels of inventory and the number of players that will be returning, that more socks, pants, and helmets will be needed. The equipment manager has organized the information in the matrix below. So here's all what they need for each of the different sports. The school has contracted with 2 supply stores in the past for equipment needs. The matrix below shows how much each store charges for the needed items. Calculate the values of A, B, C, and D in the total cost matrix. So we went from having these 2 matrices. One is a what's known as row by column, so 2 by 3, and the other one is a 3 by 2. When we have matrices like these, when this number here and this number here match up, it means we can multiply them together. So we're actually going to multiply these matrices together. So it's going to get a bit crazy here. So when we do this, we do row by column. So that means we're going to take 13 times 350, 15 times 35, and 7 times 22. Then we're going to add all those together, and that's going to give us our A value. So for 12, it technically wants us to show the calculations for A and B, so we're just going to write A and B down here. So A, like I said, was 13 times the 350 plus 15 times 35 plus 7 times 22, which is going to equal 724.50. So A is 724.50. Now for B, we're looking at the play it forever. We're still going to do the first row, but now we're going to do the second column. That's going to get us our B. So we're doing 13 times 3, 15 times 40, 7 times 45, 50. So we have 13 times 3 plus 15 times 40 plus 7 times 45, 50. And that's going to equal $957.50. So B equals 957.50. Now, we still need to find C and D. So same idea, but now we've already used the baseball numbers. We don't need to worry about those anymore. So instead, we look at the second row. So we do the second row times the first column. That's going to get us our C value. We do the second row times the second column. That's going to give us our D value. So we're going to take 24 times 350 plus 45 times 35 plus 20 times 22. So we multiply all those together, and we're going to get for C, so that equals, so C, maybe. For our C value, we get 2,099. All right, so to find D, we're going to take, once again, our football values, and we're going to multiply them to the play it forever values. So we're going to do 24 times 3 plus 45 times 40 plus 20 times 45, 50. When we multiply all that and add them together, we find that it's $2,782. So now looking at this, they would be able to determine where they want to take and buy their merchandise from for the best cost. All right. The last section that we're looking at here, representing visual patterns of change with equations and finding patterns. So your keyword for this lesson is visual. So create a table and equation for the visual pattern to the right. If you are unable to create an equation for the attribute identified, then state the pattern you notice. All triangles are equilateral, and the side length of the triangle in step 1 is 1 unit in length. So the width of the large triangle with respect to the step number. So we're going to have step number and width. So for step 1, the width is 1. For step 2, the width is 2. For step 3, The width is 3. So our equation is y equals x, where step number is x and width is y. Sorry for the weird lines. So the explanation, the step number, and the width are the same. So because they're the same, that's why we have the y equals x. You could also use other variables for this as well, as long as it's each variable equals the other, because they have to be the same. All right, number 14, the number of small triangles with side length of 1 in the large triangle with respect to the step number. So once again, we'll have x be our step number. And in this case, y will be our triangles, number of triangles. So step 1, the number of triangles we have is 1. Step 2, the number of triangles we have. So we've got 1, 2, 3 of these little blue triangles. Step 3, we have 1, 2, 3, 4, 5, 6. So what is our relationship here? So we take the previous, because we have 1, and then we add the step number. So we add the step number each time, because look, we have this one, then we add 2 here. We have this here, which is the same as step 2, then we added 3 more. We're on step 3. So our equation is y, well, this one we'll do in function notation. So it's f of n equals f of n minus 1 plus n. So now equals previous plus, we'll say x since x is our step number. So we just add the step number to the previous amount. So that's what we're looking at here. So you guys will finish out the last 3 of this. So if you guys have any questions, feel free to ask. Have a great day. Bye, guys.